The topic of the video is the significance of negative energy states that are predicted by the Dirac's equation. The eigenenergy of a free particle in relativistic regime when we solve using Dirac's equation will have both the positive and negative values. For the positive part, the expression for the energy is with positive square root of m square c power 4 plus c square p square, and when momentum approaches to 0, the minimum value of E plus can be mc squared, and then when momentum reaches or approaches infinity, then this E plus can actually tend to infinity. And for the negative part, the energy, which if you write as E minus, is minus square root of m square c power 4 plus c square p square. And in the regime where momentum p tends to 0, then its value is minus mc squared, and when momentum tends to infinity, then this will tend to minus infinity. And if we actually kind of draw a diagram where we have got the energy states for negative values, negative possible values, and energy states for positive possible values. So here for the positive regime, it is starting from mc square and tending all the way up till infinity. And here it is starting with minus mc squared, and it's going all the way up till minus infinity. And we can observe there is actually a gap between these two branches of energies, and we may actually take this thing as a forbidden gap, because the particle, Dirac's particle, cannot have energies in between these values. Dirac actually postulated that all the negative energy states are occupied by the particles. I mean, for example, if you're dealing with electrons, uh, they are actually filled with I mean, all these states are filled. We cannot have any transitions between these things, and he called this as Dirac vacuum or ground state. So yeah, as I said, Pauli's exclusion principle prevents any transition into these occupied states. So if you send light or something, light or heat energy, it cannot make any transition between these. And Dirac has taken the positive energy levels as the excited states, just the way we consider in quantum theory. So these energies belonging to mc square all the way up till infinity, they are excited states. When a photon of energy, which is energy greater than or equal to 2 mc squared, which is more than this energy gap, incidents on these energy negative energy electrons, I mean this is system, then the electron actually jumps into vacant positive energy states. And we can actually show that in this diagram here. So we had our electron here initially, but because of the interaction of incident photon h nu with energy greater than 2 mc squared, it has actually moved into the positive regime energies. So as a result, it has created a hole in Dirac vacuum, which is this one. It has created a hole, and this electron will now have electron will have positive energy. So since this photon was having a neutral charge, the resulting in a positive negative charge here, so this hole should have a positive charge, E plus. And this kind of theory was accepted when positron was actually discovered in 1932, because this was saying that every particle will have antiparticle. For example, for the case of this electron, is this hole is acting like that. So this Dirac theory predicts existence of antiparticles for every particle. That's it in this video, and thanks for watching.